and fun. Shall we? All right, let's go. How about this? Well, I don't know how brave you guys are. You all seem pretty shy for the most part. So maybe I won't put you on the spot. Or would any brave soul out there like to tell me what they're thinking, what they see? What's the first thing you see in this problem? Any brave soul? Yes, Chloe.
I see a square.
Yes! Yes! Good. Okay, a squared term. Yeah? We have a squared term. And you know what? How many of these have we seen? Dozens. So, I'm not even going to go to the toolbox. I'm going to go straight to the margin. And I'm going to take the Pythagorean identity that I know includes secant squared, and I'm going to say, all right. But here's the thing. The secant squared that's in this problem is just secant squared. So I don't have to, quote unquote, manipulate anything. Okay? Secant squared can be replaced with that statement. Now, when I look at this problem, and I think about cutting this out, and putting this in its place, is that a good idea? What do you think? I would say yes, because it's all tangents now. Okay? So, let's clean this up, because the next step might not be as obvious the way that this is written out. Maybe it is. But what could you do with this? Sorry, it's some caught in my throat. Achoo! Oh, sorry. Where were we? Oh, that's right. We were looking at this. So what's something I could do with that? Right? One of our inverted triangles. Let's decompose this fraction. Let's go on this magic carpet ride. Okay? Now, little bit of a twist. I'm going to break this fraction apart. Okay? Where the tangent squared x goes with tangent, and the 1 goes with tangent, and this plus sign. Now, stay with me on this. This is going to take it to the next level. I'll let you get caught up. So there I've split it up. Okay? But be careful. Because if I put the plus here, this is a minus, both of these. So when I split that fraction up, I've got to have the minus go here, and I have to have the minus go here. I didn't have to worry about that in the other problem we did today, because that decomposition was in the front. But now, because I'm subtracting this, when I break that into two fractions, I have to subtract both parts of that. That's the only catch on this one. Now, we can do one more thing to simplify this. Right? So we've decomposed. Tangent is tangent. But tangent squared over tangent, this is tangent tangent. Right? Tangent squared. Tangent tangent over tangent. would imply that I could cancel this with one of these. See what I'm doing there? It's not tangent, tangent anymore. There's just one tangent on the top. If I'm taking too much of a big step here, I'll write it small right here. Tangent squared x is tangent x squared, which is tangent x, tangent x. So this is what I have up here. So by crossing off the 2, I don't have 2 of them, I have 1 of them, and I'm canceling it with that one. Okay? So now we have tangent x minus tangent x minus 1 over tangent x. And I don't need to go to the toolbox. I went to the toolbox twice. Once to do the squared term thingy, and once to decompose the fraction. Now I'm just simplifying. These are opposites. They're going to cancel each other out. I'm going to have negative 1 over tangent x. And if you left that, I'd be okay with it, all things considered. But, just like I can write cosine out of the fraction as a regular secant, I can write a tangent out of the fraction as cotangent. But if you left this, I'd be pretty happy about that. Okay? That was it. That was our last simplification. Congratulations.